Welcome to Cheenta School of Statistics and Data Science. Today we will solve the problem number 25 and 37 of GATE 2022 statistics paper. The problem 25 says that let x and y be two independent exponential random variables with given expectation of x is equal to half and expectation of y is equal to 2 by 9. So we need to find probability of x equal to 2y. So for that, let us assume x follows some exponential theta 1 or theta 1 greater than 0 and y follows some theta exponential theta 2 or theta 2 greater than 0. So the form of PDF considered here is if x for u follows some exponential lambda, then PDF of u is 1 by lambda into e to the power minus lambda into u for u greater than 0, lambda greater than 0. Okay. So from the given PDF, we got expectation of u equal to lambda and variance of u equal to lambda square. So using this, we can get expectation of x square equal to variance of x plus expectation of x whole square. Since variance of x equal to expectation of u square plus minus expectation of u whole square. So replacing these values into this equation, we can get the equation. So from that we can get variance of x is coming out to 1 by theta 1 square, and expectation of x is also the 1 by theta 1, so its square is 1 by theta 1 square. So adding up we get 2 by theta 1 square, which is equal to half, which is given. So from that we get theta 1 equal to 2, and similarly from the given condition of y we can get theta 2 equal to 3. Now x follows exponential with mean 2 and independent of y following exponential of mean 3. So x and y are two independent exponential random variables with the specified parameters. So the joint distribution of x and y is given to be xy equal to 2 into e to the power x e to the power minus 2x into 3 into e to the power minus 3y for xy greater than 0 and 0 otherwise. So we can write the PDF as in the form 6 into e to the power minus of 2x plus 3y for x greater than 0, y greater than 0 and 0 otherwise. So to find the probability of x less than 2y, we need to integrate in that part, as we have see the probability of some a, that is x belongs to a, equal to integrate over the region a of the given PDF or PMF. So this formula gives us that 0 to infinity, 0 less than x less than 2y less than infinity. We need to find this required probability, and we also have x greater than 0, y greater than 0. So the range is coming out to be x equal to 2y, the line. So this passes to x equal to 2y line, and we need to find the region x greater than 0, y greater than 0. And we also need to find the region x less than 2y, where x is less than 1. So this is the point 1, 0. So here x is greater than 2y. So this will be the certified region. So we first take the value of x to be 0 to infinity, that is this point, and then y will vary from x by 2 to infinity. So we divided the integral in two parts. One is the limit of x 0 to infinity, and second is the limit of y x by 2 to infinity. So integrating the part of y from x by 2 to infinity, we get 1 by 3 into the minus 3y, and putting the limit, we get the integral as 0 to infinity e to the minus 7x by 2 dx. So solving this integral, we get the value is coming out to be 4 by 7, which is nearly equal to 0.57. As in NAT section, we have to write the rounded up to 2 decimal places. The answer would be 0.57. So next, we will move to problem number 37. So this problem says, given that S1 and S2 are given to series. So S1 given by the series n equal to 0 to infinity minus 1 whole to the power n into n by n square plus 4. And S2 is given by the series n equal to 0 to infinity minus 1 whole to the power n into root over of n square plus 1 by minus n. So we need to find which one of the series is conditionally convergent. So for that, let us first consider the series S1. So S1 equal to, we can write it as a summation of some un, where un is the minus 1 whole to the power n into n by n square plus 4. So the absolute value of un will be n by n square plus 4. And from the equivalence test, that is if summation bn equivalence summation an, then bn converges with an, and then if an is convergent, then bn is also convergent, and if an is divergent, then bn is also divergent. So here an is the series 1 by n, it is divergent, and you can say that the series summation n by n square plus 4 is also divergent. So the series S1 is not absolutely convergent here. Now again, S1 is this, we can write it as minus 1 whole to the power an, where here an is n by n square plus 4. So we check the limit of n tends to infinity an. This is coming out to 0, and an is greater than an plus 1. So an is a sequence of, is a decreasing sequence. So by Leibniz rule or Leibniz theorem, we can say that S1 is convergent. So S1 is convergent, but not absolutely convergent. Hence, we can say that S1 is convergent conditionally. Now for S2, similarly, proceeding similarly, we can get it is some, we can write it is some n equal to 0 to infinity tn, but tn equal to minus 1 whole to the power n, 1 by n square plus 1 minus plus n. We can just rationalize it and get this form. So the we now check the absolute convergence of S1. So summation of modulus Tn is coming out to be equivalent to summation of 1 by n. So which is not convergent. Hence we can say so S2 is not absolutely convergent. Now S2, you can write it as minus 1 into Qn, where Qn is that term n square plus 1 root minus n. So this limit is coming out to be 0, and Qn is a monotonically decreasing sequence. As you can see, if Qn plus 1 is less than Qn, from here it is only coming out. So by two conditions are satisfied, that is limit of n tends to infinity Qn equal to 0 and Qn is decreasing. So by applying Leibniz rule, we can say that S2 is convergent. Here also S2 is not absolutely convergent, but S2 is convergent. So we can say that S2 is conditionally convergent, and hence both S1 S2 are conditionally convergent. So option C is correct. So that is all for today. Thank you for watching. I will see you in the next video. Till then, stay blessed and stay tuned.